We have been discussing about C programming in module 1. This is part 2 we will now talk about. So, in the earlier part you have seen the basic concepts, elementary concepts of C, including data types, variables, operators, expressions and statements, particularly the control statements. So, now we will move on and we will talk about various derived types in C. As you know, the most common derived type in C are arrays. Array is a collection of data items. So, a variable is a single data item, it is a single value, whereas array is a collection of one or more data items, with the restriction that all data items have to be of the same type. So, if I say there is an array of int, then everything in that, all value in that array has to be int. If I say the array is of type char, then every element has to be of type character. So, in terms of arrays, the first thing we need to do is to declare an array, like we need to declare any variable. So, we declare the array in this. So, naturally we need to specify the name, we need to say what is the type of the element of an array, and also we need to specify what is the maximum number of elements that an array can support. Now, this maximum number of elements can be specified in multiple different ways, and as we will see that this is one aspect in which arrays in C++ will somewhat differ from arrays in C, but a typical array in C will be defined as double balance within corner brackets 10, which will say that balance is an array of double type elements and maximum 10 such elements could be there. Otherwise, we can define a size by a manifest constant and use that to define the declare the array. Then array can also be initialized. We are moving to the second part. So, arrays can also be initialized. That is, if I just declare an array, then the elements do not have any specified value, but I can declare as well as initialize the array. So, if I say int primes 5 initialized with this list of values which are separated by comma and is contained within a pair of curly braces, then the first value in that list goes to the first element of the array, which is the 0th index element, as you know. The second on the list goes to the second element, which is at the index 1 and so on. Interestingly, in C, arrays are allowed to be initialized even without a specifically expressed size. So, I can just write primes without actually giving a size and just give the initialization list. What C compiler does, it finds out how many elements you have initialized it with and assumes that is the size of the array or those many elements will be there. So, if primes are just initialized with the list of 2, 3, 5, 7 and 11, there are 5 elements. So, it will become an array of 5 elements, and I have also shown in such cases, since you do not know what is the size, what is the most reliable way to compute the size. That is, you find what is the total size of the array divided by the size of every element, you will certainly get the number of elements that the array contains. It is also possible that you have a bigger array and initialize it with less number of elements. The initialization will always happen from the beginning, and the remaining elements in such cases will be initialized to 0. But you cannot have an initialization list which is bigger than the size of the array, that will be an error. An array, whether it is initialized or not initialized, can be accessed by each and every element. So, next, for accessing array elements, we can see that we use the index and we can read or access that element which exists at that array location. Similarly, I can also write it on the left hand side of an expression and make an assignment to an array element. C assumes that every array as it is defined is like a single element also. So, I can define arrays of arrays and of arrays and of arrays and so on, and in this way I can extend into multiple dimensions. So, these are called multi-dimensional arrays. So, the simplest of the multi-dimensional array would be a 2-dimensional array, which we commonly in mathematics we commonly call them as matrix. So, it is given with 2 dimensions, one is the number of rows and the number of columns. So, if we define int mat 3 4, that means that there are 3 rows and 4 columns in this whole mat array that we have. So, it makes it 2-dimensional. Naturally, if it is 2-dimensional, it needs 2 indices, the row index and the column index to be accessed. You can extend it to 3 4 any higher dimension as is required, but it is less common that you will have 3 or higher dimensional arrays in regular use. Next to arrays are structures. So, like array is a collection, and we will slowly start using the term container, a term which is not so common in C, but we will see in C++ and particularly the standard library that comes with C++. The terms commonly used is called container, because container is something which can contain other elements. So, array is a container, it is a collection of data items with the specific behavior that all items are of the same type, as we have said. Now, structure in contrast is also a container, it is a collection of data items, but here the data items could be of different types. It is not necessary that they have to be of different types, but they can be of different types. So, if I look into a structure, these data items are often called members, and we will more and more use this term member or data member to mean components or data items of a structure. We show a simple example of forming a complex number. As we know, complex numbers have 2 components, the real part and the imaginary part. So, each part can be a double. So, we define that with struct complex, that tells us that there are 2 components. In this case, both of them are of the same type, and then C is declared to be a variable of this structure type. We can also, in the next one, we show that you truly have one structure where components are of different types. So, the first 2 components in the book's structure are title and author. They themselves are arrays of character, which is basically what it means, that they will become C strings of title name and the author name, and the third component is actually an integer, which is keeping the book ID. So, structures could be defined directly as by their name, and using the keyword struct we can use that, or the struct and the structure name can together be given an alias by the use of typedef keyword. Typedef is a short form of type definition, and as we go into C++, we will talk more about this, that why typedef actually is not a type definition. It is kind of a misnomer, but historically it has, this keyword has been used and it continued to be used in C, but it is basically a type alias. It is just another name given to the struct complex or the struct books as we have. It just becomes it easier. So, if you have a typedef, then you can directly use it. So, if we come to the access of the structures, then you can see that since complex was just defined as struct complex, to use that we need to write struct complex and then the variable name followed by the initialization, of course. But books here was defined by typedef. So, books does not need to be written with struct books, I can just write books, it has given a total name for the struct book. So, it becomes easier to use it in that way. Now, any structure variable can be initialized like a simple variable, and the notation is very similar to the way we initialized arrays. In contrast, in arrays the list formed within curly braces meant different components or different indexed elements of the array. Here in case of structure, it means the different components or the data members of the array, and the way you list these initialization values are the way the data members are listed from the top to bottom order. So, if we look into the specific cases given in this code, then we are showing struct complex x initialized with 2.0 3.5, which means 2.0 will be the initial value of the first component, which is RE. So, you just read them from top to bottom and read this list from left to right and correspond them. So, 3.5 will be the initial value of IM. So, x will become a complex number 2.0 plus j 3.5, if we think of it that way. It is possible that we initialize only one or a sum of the members, but you can do that only from the initial part starting from the top. You cannot skip RE and just initialize IM, but you can initialize RE as you are doing here with 4.2 and skip IM, which is not mentioned here. Then every component of a structure can be accessed by the dot notation, the dot operator we are showing here. So, if x is a complex variable, a structure variable, then the RE component of this variable x is written as x dot RE. Similarly, here book is a structure of the above type, books type. So, it has a ID component, which is book dot ID. So, we use the dot notation to access the structure components. So, we can see amongst the two most commonly used, two most powerful containers in C has two different ways of access. Array, since all elements are of uniform type, it is accessed by position. It is called the positional access, because you want to find out in the array starting from the beginning, the 0th, first, second. So, you just go by number. So, array is also called a indexed container, because you can access the elements by number. In contrast, in structure the elements are of different components are of different types. So, there is not much significance to what is a first component in the list or what is a third component in the list and so on. So, you would access the elements by name. Now, this is also a style which you will see in different languages as to whether you can access something by name or you can access something by position, and similar issues of access will come up when we talk about function arguments also, which in C, as you know, is also by position. And I would just like to highlight that these are few common aspects of programming languages that you need to be careful about as to when you have a list of elements, what is the access mechanism between whether it is positional or it is by name. So, in structure we see one kind, in array we see the other. Now, moving on, C supports another kind of collection container, which are pretty much like structures. They are called union. Now, the only difference is instead of using the struct keyword, you use the union keyword. The way you specify or way you access the members are same between structure and union, but what is different is the way the memory is allocated. If you have a structure with 2, 3 different members, then when a variable of that structure type is created, all members are allocated area. So, if you go back to if you go back to this structure, then you will see that here after the complex structure has been defined, it has 2 components. So, both these components are actually allocated. So, if we assume that every double takes 8 bytes, then the size of the whole complex structure is 8 bytes plus 8 bytes, that is 16 bytes, because both exist. In contrast, in union, it is the allocation is done in memory for only the largest component. So, you make sure that your basic assumption is, as the name union suggests, that this is a union of all these fields. So, at any point of time only one of the components will exist, only one of the components has to be assumed. So, naturally if you are representing only one of them, you need enough space for the largest one. That is only the logical thing. So, if we look into this union packet, then we will see that in packet int 3 components are of int, double and cat type. So, if we take a reasonable assumption about the size in a say a 32-bit machine, then int will be 4 bytes, double will be 8 bytes and cat possibly will be 2 bytes. So, the size of packet will be 8 bytes, which is the size of the largest component double. So, the interesting aspect is this on one side allows you to minimize the size of the whole record, the size of the whole container, if you know that you do not need all the components at the same time. So, when you but the flip side is when you initialize, you are initializing only the value of the first component, because certainly here since you can have only one component, we have space for only one component, the initialization cannot have a list of components, list of constants to initialize different data members. And we have seen that an initialization can be partial, provided I have initialized the first one or the first two or the first three. Here since there is only one data member, there is only one value that you can initialize, and that has to be the type of the first value. Otherwise, you will have to, you will not need to initialize, rather you will simply take the component and assign that. So, in terms of access, the same dot notation, the dot operator will be useful for accessing the different components, but the point is you will have to remember that only one value is maintained out of, though we have 3 components, there is only one value. So, depending on what is the component that you have assigned last, when you access, the value of that component only will be valid. If you access a different component than what was assigned last, then you will get unexpected result. So, in this access code, if you look at little carefully, then you will see in the first part of the code we see that I data, the integer we assign 2, and then we access I data. So, 2 is printed. In double data we do 2.5, access double data 2.2. So, double data we access, the 2.2 is printed. In the cat data we assign constant character a, we access that, a is printed. So, whatever we access last is what is printed. Now, in the next we show an interesting thing, we in the I data there is the integer part we assign 97, and then we access the integer data, obviously 97 is printed the last. But if without assigning anything we access it as D data, then you get some 2.19999, which is not something very meaningful. So, this is happening because the D data, double data has much larger size, 8 bytes, whereas you had assigned I data, which means that you have only assigned 4 bytes of that. Remaining 4 bytes have some old garbage value. So, what you get as D data is completely wrong. The final interesting thing is if you access it as C data, then you are actually accessing 97 as C data, and you see you are getting A. Why? 97 is the ASCII code of A. Now, the interesting thing is that C data possibly is 1 byte here, which means that it can contain up to 255. The value incidentally that you have given to the 4 bytes of int happens to be less than 255. So, we can easily understand that in this int the higher 3 bytes are all zeros. So, when I access it as a character, I just get the 97 that I have stored there. So, it feels as if I have got the correct character value, which is the code of A. The point that I am trying to highlight is it is one value that resides because there is only one memory location. You will have to be very careful about this when you are using union. The reason union was given in C is for the fact that if you have to make an aggregate, if you have to make a container which can deal with data of variety of types, typically just to give you the kind of reference where union is used, is if you think of a network connection and you have a network port where variety of data is coming, different kinds of data packets are coming, and you do not know what kind of data packet will come out of a possible say 10 different kinds of data packets, but you know that at any point of time only one kind of data packet will come, only one data packet will come, then how do you define a programming structure to store this data packet? Now, you do not want to make a structure which has the possibility of storing all these 10 different kinds of data packets, because that will unnecessarily take a lot of space. But at the same time, utilizing the fact that only one type of packet will come at one point of time, you could use this union structure as a collection of all. So, that is how it has been used in C, and we will see in terms going to C++, there will be a lot of ramifications of this concept of union. C++ does provide us with a very strong feature based on object orientation, something known as inheritance and specialization, and we will see how similar effects can be created in C++ without using union. So, that is just for your comments. We will come to the details subsequently when we go to that level of C++. Now, next, the most interesting and possibly one of the most powerful feature of C programming that comes up. C programming, if you are familiar with a little bit of the history of the language, and I seek this to be an appropriate point to introduce that to you, is before C was done in an university by a group of computer scientists, professors typically, and a group of professionals, we were trying to write an operating system which later on became popular as Unix. You all use Linux, which is a much later generation of that. So, while they were trying to write Unix, trying to write code for Unix, they needed a programming language, because otherwise how do you write code? Now, prior to Unix, there was no high level programming language of the type that you see in C or C++ or Java or Python available, where you could write an operating system, because when you want to write an operating system, you need to not only deal with values, but also you need to deal with memory, because the programs will finally get stored in memory, the data will reside in memory. So, when we write a program, we are just dealing with variables, we are just interested about values. We can write a complete program like in Python or in Java without at all thinking of where these values are stored in memory, but you cannot write an operating system assuming that. You need to that programming language to be aware of the memory or to be aware of the address where values get stored. So, that was one of the various reasons for which the team of Kernighan, Ritchie and Maurice Bach and all others who were in the Unix team needed to do a programming language, and they quickly designed C, which then later on became a default language for all of us. Rest of it, as they say, is history. But this is the genesis for which C for the first time introduced the strong concept of managing addresses as data, and that is what we say is a pointer. And I just wanted to give you the reason why you needed this, but when you have this feature of dealing with address as data, that gives C a very strong background in which C can create variety of data structures, as you all some of it you all have already done. Like you cannot think of doing a list without having pointers. It is possible, you can have create a linked list by using two arrays, an array to keep the index, the address of where you will find the next element, and another array to actually have the values, but that is not something which is efficient, which is scalable, which what people would do. So, you will always use pointers. So, pointers are the next derived type, as you all know. So, it is a variable whose value is a memory address, and the type of a pointer is decided by not by the pointer itself, all pointers are addresses. So, address it has only one type, that is of the pointer type, but their type is decided based on what kind of value they are actually pointing to. So, if I have a int star I p, then it is pointing to an integer type of value. So, we will say it is int star type. Now, to use pointer, you will be familiar with this, then I can have a variable I which is initialized to 20, I have a pointer I p which I would use to point to I, which is int star I p, and there is a special operator ampersand, as you know, which I can use with any variable to get the address of the memory location where this variable will be stored. So, I can take that address and store that address in the pointer variable I p. And once I have done that, then if I try to print the address of variable I, or I print the address or the value of I p, which is actually the address that I have stored here, then they will certainly be identical. That is what we are showing here. Now, given that address, I can actually find out what value exists at that pointed location by using the star or content of operator. So, here along with the pointer, we will always use the address of as well as content of operators. Now, pointers can be used in multiple different ways. They are very powerful in terms of creating various idioms in the programming language. The first and the most common is the duality between a pointer and an array, and most easily seen in terms of an one dimensional array. So, array is a series of locations and pointer is the address of the starting location of the array. So, I can take the array and assign it to a pointer variable, and then if I just do star p, it gives me the content which will be the content at the starting location of the array, which is will happen to be A0. I can increment a pointer, and that is a very interesting concept. If I increment a pointer, then the amount by which it is incremented is not 1. The amount by which it is incremented is the size of the type of element it is pointing to, type of value it is pointing to. So, if it is pointing to an int and the size of int in the system is 4, then the pointer value actually will increment by 4. So, that in terms of the array, now you are pointing to the second location. So, you can see that if I do star plus plus p, it will first increment. So, it is now pointing to element 1 and then it takes the element 1, which is basically 2. Similarly, I can take p plus 1 as an expression. P plus 1 similarly is the current location of the pointer plus 1 element size, what that can be used. Pointers can be used with structures. If we use that, then we can access the elements by star p, and then star p is the structure that it is pointing to, dot re is the component of that structure. This can be shortened by a dereferencing operator as is given in C, you know all this. So, we will skip that. Then pointers are also used in terms of dynamic allocation. So, I can dynamically allocate using malloc, and I get a pointer which does not have a specified type. We say that is a void star, and we can use a casting which is forcibly to be done by the programmer to cast that to an integer type value. This is an interesting code given here. I will not go through the details, try to understand how this code works, how to manipulate with pointers, and if you have questions, you can ask us on the blog, and we can use pointers for dynamically allocating arrays as well. So, with this in this part of the recap, we have primarily talked of the different derived types. First, we have talked about the containers, arrays, structures and unions, the 3 main types of containers that C provide, and we have talked of managing the different variables and addresses through pointers. In the next, we will talk about the functions.